Hello everyone, this is Alessandro Ferretta. I'm going to be presenting how to read phylogenetic trees. It's just going to be a brief overview on how to read the trees and what goes into making them, some of the characteristics of the trees, and just some general information about them. This is for the Explain Everything presentation, and I'm going to go ahead and get started on this. So this is some general terminology first off here. As you can see, we have those blue highlighted endpoints on those branches there. The branch is highlighted in green. The blue point is the extant species there. And so what that means is from the common ancestor, which is located at the node. From there, the organism has branched off, and at the blue point, that is where the organism has evolved and what the organism would have been observed as. So, organisms 1 and 2 are going to be ancestral species that were evolved from that common ancestor at their branch point. And we see organisms 3 and 4. Those are actually the most common and most fully evolved of the species that are from that common ancestral node. And you'll see this big arrow here. It's showing that the tree should be looked at and read in this direction, going from the bottom up to the right. And in the upper right, like I said, are the most recently living species. They're the most evolved from the original common ancestor. And 3 and 4 would be most closely related in this tree. And then we have organism 2, which would be more closely related to 3 and 4 than 1 would be. And 1 is more closely related to number 2. So that just shows a brief overview on how to read the tree itself. So here's some more general guidelines. This is just showing rotation around nodes. And what rotation around nodes does is really just changes the conformation of how you see the tree. It doesn't really change any lineage information or evolutionary information, stuff like that, based on the taxa here. All it does is just rotate around the node, and it's just pretty much a physical change in the way the tree looks. So another general term we have here that is commonly used with phylogenetic trees is the concept of parsimony. And what parsimony is it is the term used for explaining the most simple form of the tree. So it's essentially saying that the most simple way to reach a conclusion is usually most favorable. Now, this doesn't necessarily mean that the tree is in its most correct form, but what it does say is that it's the most concise and direct way of explaining that tree. So here's another term we have, and these are often seen in trees too. It's a polytomy, and I have a normal tree drawn here on the left side, and on the right is a tree with a polytomy. And what that is it is shown in a tree where there's some confusion in the divergence of organisms. So maybe it's unclear which organisms branch off where, and so it's just drawn as a polytomy. It's that little star looking thing in the very top right of that right tree there. Or it's also used if the organism, the ancestral organism, has many other branching organisms off of it. So what it is that there's more than two usually branching off. So that's just another way to draw that and try and explain that form. So I'm going to go ahead and wrap it up with this last slide here on monophyletic, polyphyletic, and paraphyletic. Monophyletic here is the one that's shown in the purple highlighted in the top right. And what that means is that it is the most recent common ancestor and all of its descendants. So we see that clearly highlighted there. For paraphyletic, that's a little different than the monophyletic. What paraphyletic is that it includes the most recent common ancestor, but not all of its descendants. So it just highlights that very left side there for paraphyletic. And the last one I'm going to go ahead and explain is polyphyletic, which is defined as it does not include the common ancestor, but it does include some members of those extinct groups, showing a relation there. Alright guys, so that was just a brief overview on how to read and formulate some trees here, and I hope you guys enjoyed. This is Alessandro Ferretta, and this is my Explain Everything project.